Hello everyone, we have two questions here. First question is where assertion is charge carriers do not move with acceleration but with a steady drift velocity. Means charge carriers does not move with acceleration but they have steady drift velocity. And the reason for this is charge carriers undergo collision with ions and atoms during transition. And the next question is when electron drift in a metal from lower to higher potential, does it mean that all the free electrons are moving in same direction? Now we are going to solve both of these questions in one go. So to solve these questions we have to take a elementary idea of drift velocity. So our metal consists of large number of free electrons, and this large number is nearly 10 to the power 29 per meter cube. That much large free electrons are present in metals. These electrons at room temperature move at random within the body of the conductor, just like the molecules of gas. And the average thermal velocity of these free electrons in random motion is of the order of 10 to the power 5 meter per second. What does it mean? It means if we have a conductor, so there will be zigzag motion of electrons due to its thermal velocity, and this average thermal speed of electrons is of the order of 10 to the power 5 meter per second. Now the direction of these free electrons are so randomly distributed that the average thermal velocity means individual electrons have thermal velocity in a random direction, but average thermal velocity of all these electrons is zero. Average thermal velocity equal to 0. So we can say that if u1 is the individual velocity of one electron and u2 be the of second plus un be the average velocity of nth electron, then the average velocity is 0. And as a result of which there will be no net flow of electrons in a particular direction in a metal conductor. So there is no current because there is no resultant motion of electrons in a particular direction. That's why there will be no current. But when some potential difference is applied across the ends of metal conductor, then an electric field is set up inside a conductor. So let us suppose we have a conductor and we have connected it with the source of EMF. Let us suppose this terminal we have made negative and this terminal we have made positive, and we have applied electric field here. So this terminal is at positive potential and this terminal is at negative potential. So when we applied some potential difference across the ends of the conductor, then electric field is set up inside a conductor, and as a result of which the free electrons of metal experience a force in the direction opposite to electric field, because the direction of electric field will be from positive to negative in this side, and the electron will get drifted towards the positive end of the conductor. So electron will get deflected in this direction. So they are moving opposite to the electric field, and they are accelerated from negative end to positive end of the conductor, and on their way, mm, suppose electrons are drifted. Ideally electrons must be drifted in such a way, but there are there are ions and atoms also in this copper or conductor, in this copper metal or any conductor. There are ions or atom also, so these electrons will collide. So these electrons will collide with these ions and atoms, and on their way these accelerated free electrons suffer frequent collisions from these ions and atoms and lose their kinetic energy. And after each collision, the free electrons again accelerated due to electric field, and then again there will be collision from the next ion or atom. It means the extra velocity gained by electron is lost in subsequent collision, and this process continues till the electron reaches the positive end of conductor. So under the effect of electric field, the free electrons are having random thermal velocity acquired small velocity by virtue of acceleration due to electric field, due to which they move towards the positive end of conductor. These velocities, note my point, these velocities are in different directions, and this is the question. This is the answer of second. This is the answer of second question, that these velocities are in different direction, due to which each free electron describes a curved path between two successive collisions. So ideally this must be the path of electron, but because of collisions, our charged particle, let us suppose it started from here, then it get drifted due because of electric field, then it suffers a collision from here, then it will move after collision this part, and then it also suffers collision, then it will move this part, and then this part, then this side. After successive collision, these electrons follow the curved path to move the positive end of conductor. So we can say here these electrons does not move in a same direction. They move in a different direction, and that is the answer of question number second. Now the electrons drift towards positive end of the conductor with some average drift velocity, and this average drift velocity of electrons, it is of the order of 10 to the power 5 minus 10 to the power minus 4 meter per second. So you can see here that how much is our drift velocity. So drift velocity is of the order of 10 to the power 4 minus 4 meter per second. So let's have a look our questions again. So our assertion is charge carriers do not move with acceleration but with a steady drift velocity. Obviously, because charge carriers initially accelerated with the help of electric field, but after collision they lose their acceleration. So they move, and because of collisions they move with steady. It means they move with they do not move with acceleration, they move with steady drift velocity. Steady means nearly constant drift velocity. Now because of collision, and the reason of this, because charge carriers undergo collisions. And the second question is When electrons drift in a metal from lower to higher potential, does it mean all free electrons are moving in same direction? So we have seen these all electrons does not move in same direction. We have seen in there because of collisions there are different direction of motion of a particular electron while drifting towards the positive end of conductor. So we have solved both of these questions in one go. Thank you.